All right, so as we take a look here at number 29, we're asked to decide whether the relation is a function and give the domain and range. All right, so this is similar to, I think it was 25 and 26 earlier in the practice test where we were given a set of points and then asked whether the relation was a function or not. Now we're given a graph and asked the same question, is this a function or not? And when you're given a graph, it's usually much easier to determine whether or not it's a function because all we have to do is use the vertical line test, which you hopefully recall from class. And all that means is we're going to take our graph, drop a vertical line through that graph, and see how many places does our vertical line touch. If our vertical line only touches in one place, then we have ourselves a function. If it touches in more than one place, we do not have a function. And you can see that we can draw vertical lines all over this graph, and we are always only touching in one location. So we definitely have ourselves a function here. So because we have a multiple choice question here, and we definitely know this is a function, let's go ahead and we can go get rid of B and C, because B and C says this is not a function, but we just established it is. So now that helps us. We have a 50-50 chance now, if we were taking a test, of getting this question right, don't we? Because we've eliminated two answers that we definitely know are not correct. All right, so now we're asked whether or what the domain and range is, and you'll recall that domain refers to our x values, right? And the range refers to the y values. All right, so let's go ahead and deal with domain, our x values. All right, and if this is a line, and it is, then this line, we'll presume, has arrows on either end, even though it's not shown here on the practice test, but it does. We'll go ahead and add them. Then this line goes on in both directions forever, and I probably shouldn't have added that parentheses. We'll jump ahead a little bit. All right, and so since this line goes in both directions, up and down, forever and ever, it never stops, we can see that as this line heads up, as it goes up, and again it extends past this graph, what's happening with our x values? Well, let's see. Well, if we're just, and I'm just randomly choosing a point here on the line. Well, here, let's see, it looks like our x might be 1, 2, somewhere between 1 and 2. But if we go up a little bit more, now our x is at 1, right? If we go up a little bit more on our line, we can come down. Looks like now we're at -1. If we keep going up on this line, well, now it looks like we might be at -3 or -4. And we could keep going and going and going, and you would see that our x values on this line are continually getting smaller and smaller as this line grows, gets further and further up. And it's heading towards what number, or what in what direction? It's heading left, getting smaller, heading towards -infinity. All right, and similarly, if it's getting closer to -infinity as the line goes up, well, what must it be doing as the line goes down? Well, let's see. Well, again, here on the line, we're getting an x value of maybe 1. As we go down, 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 well, now we're getting an x value of 3. We can go a little bit further down now, and now we're getting an x value of 5. Going further down, well, now we might be getting an x value of 7. So you can see that as the line gets further and further down, goes further down, the x value is increasing, and it's heading towards positive infinity. All right, so this line is getting further and further to the right, and as it does, the x values are increasing. As it line increases up, the x values are heading towards -infinity because they're getting smaller. And so we're saying then that the x values, the domain, remember we always start with a smaller number, and in this case we're dealing with, it's heading towards -infinity on the left, and it's heading towards positive infinity as that number goes to the right. And because infinity, -infinity and positive infinity, are not really numbers, it's more of a concept. We don't really know what infinity is. We're using parentheses, and we use parentheses when we mean we don't want to include the value that we have listed here. And the reason that we're not including infinity is because we don't know where infinity is. So we're saying whatever infinity is, since it's just a concept, we're going to go ahead and use parentheses instead of brackets. And we'll talk about brackets, I think, maybe in number 30. All right, let's talk about range now. And we'll go ahead and get rid of our little drawings here. All right. So again, this is a line. It's going on and on in both directions. And as this line gets larger, goes up, what's happening to our y values? Well, let's see. Well, here on our line, our y value is 0. As the line goes up, 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 well, now our y value is 5, right? Goes a little farther up. Well, now our y value is 10. Goes a little farther up. Well, now our y value might be 15. So as the line goes up, we're heading towards positive infinity. And as this line moves down, it's heading towards negative infinity, right? Here on our line, our corresponding y value is 0. If we move a little farther down on the line, now we're at -5 for the y's. Move a little bit farther down. Now we're at, -11, -10, somewhere there. So as the line goes farther down, our y value is getting smaller. All right, so for our range, asking for the y values, again, negative infinity to positive infinity. And so we're looking at D here. All right, that wasn't very good. I'll just circle the letter. All right, so let's go ahead and take a look at number 30. Again, decide whether the relation is a function and give the domain and range. Well, the first part's pretty easy, right? We're just going to drop a vertical line through our graph and see what happens. Well, we touch one place, touch two places, so right away we know this is not a function. All right, and now it wants the domain and it wants our range. So let's take a look and see what that means. All right, so again, we're going to pretend that there are arrows on both ends of this parabola. And we can see that this graph is definitely, as it heads towards the left, the x values are getting smaller, aren't they? Because here at the vertex, the point at which this graph turns around, which looks like the point is -3, 1, 2, +2. As this graph you can kind of say, I guess, starts here at -3, the x value, and it is going towards the left in both directions, and it's only getting smaller, those x values. All right, so remember, x values, what is this heading off towards? Negative infinity. And as it moves towards the right, the x values are getting larger. So all the way out at negative infinity, as it starts moving right, they're going to start getting bigger and bigger and bigger, and eventually we get to -10, 9, -8, -7. We get to -5, -4, and -3, and then we stop. This graph will never ever have any x values larger than -3. So the x values, the domain for this function, for this graph, or not, this is not a function, excuse me, for this parabola rather, goes from negative infinity to -3. And because -3 is a real number, we know what -3 is, we're going to go ahead and use a bracket here. All right, now let's go ahead and talk about the range, the y values. All right, so for the y values, if you pretend that each side of this parabola is a handle, and you take this and you grab onto each side, kind of like bicycle bars, and you stretch it and pull the bars towards the y-axis, you're ostensibly stretching this parabola out, and what you're going to end up with is a vertical line pointing up and down. And when you have that, it makes it a little easier to see what the possible y values are for this parabola. As the graph heads down, it's heading towards what? Negative infinity. And as this graph heads up, it's heading towards positive infinity. And so we can say then that our range is negative infinity to positive infinity. All right, and if you're struggling with these, just know that you're in good company. A lot of students struggle with finding the domain and range from a graph, so please make sure that you come into the SLC or go to the pass room, BB314, on the Gardens campus and see a tutor and get some additional help, because these are, like I may have mentioned, are really easy points on a test. You'll definitely have one or two of these on your test, and you don't want to miss these. It can be a little confusing at first trying to figure out what the domain and range is from a graph, because you kind of have to visualize and manipulate the graph that you're given in your head. So I can certainly understand if you're having some challenges with this, but please come in and see a tutor and make sure that you get some clarification on domain and range.